Okay, this video is to show how you draw a ray diagram and do the calculations for an object if it's located inside the focal length. This would be like a makeup mirror where you see yourself bigger and right side up inside of the mirror. So we do our ray diagrams, but they're going to be a little bit different than the ones you've seen for the real images. What we do is we still draw a ray. A ray coming in parallel to the principal axis is going to reflect off back through the focal point. Like this, okay. And in this case, another convenient ray to draw is one which would seem as if it was going to pass through the focal point. And that's a ray which, if we kind of draw a line like this, okay, that's a line that would pass through the focal point if it came from that direction and from the tip. That line is going to pass out parallel to the principal axis like this because of the geometry of the situation is still the same when it hits the mirror. Now, as you can see, these light rays are diverging, okay, which means they're spreading apart. If we take a look on this part of the mirror, they're not coming together out here. So somebody which is looking back along those rays are going to see those rays coming from the position as they appear behind the mirror. So what we'll do is I'll trace those back using a dotted line. We'll just continue this line straight on back this location like this, and we'll continue this one straight on back this location right about like that. And where they cross is approximately where the position of the candle flame would look to be appearing from. It's 1, 2, 3, 4, 5, 6, 7, 8 squares back. That's roughly right about here. Okay, now this is a rough approximation. So people would see a candle flame at about that position, and that whole candle, if we did a point diagram for every single point along that candle would appear to be magnified and right side up. Okay, so let's take a look at the calculations for this. All right, our object location, P, is in front of the mirror, so it's positive, and that's 1, 2, 3, 4, 5 centimeters in front of the mirror. We're going to calculate the image location, Q, and the focal point is 12 centimeters for this mirror. So solving, we'd have 1 over Q is equal to 1/12 minus 1/5. Solving on your calculator for that, you'll get negative 0.1167. And if we invert that, Q is going to equal negative 8.57, which is pretty close to our ray diagram's location. The negative sign tells us that it's a virtual image because Q is negative for objects which are located behind the mirror. Okay. Now let's take a look at our magnification, and we should get a bigger number for the magnification, a number bigger than 1, because our object, or our image, obviously appears to be larger than our object. So a magnification equaling negative Q over P, that's going to be negative 8.57 divided by P, and in this case the object location was 5 centimeters. So if we do that calculation, we're going to end up with a positive number, and positive 8.57 divided by 5 gives us 1.71, so positive 1.71. So we have an image which is magnified. The positive sign indicates that the image is going to be upright in this case. So we have a virtual image because it's located behind the mirror, it's magnified, and it's upright.